It is important to understand that not only can your data be different types, remember the categorical, qualitative, or numerical, quantitative conversation we had earlier, it also has a scale of measurement associated with it that describes what the values mean. This is important because the interpretation of statistical analysis is based on underlying assumptions about the type of data and its scale of measurement, among other characteristics. Just because you can run a statistic on some data doesn't mean that the results will actually make sense. Further, different visualizations or charts should be used depending on the scale of measurement and data type. Data can be nominal, which means that the values associated with that variable represent identifiers. These are unranked categorizations. For example, demographic information such as gender, race, or ethnicity, color of a car. Those might be nominal. Because you can only do statistical analysis on numbers, not words, you would have to assign a code to differentiate between genders, for example. This is what we call a dummy code. For example, you might characterize women as 1 and men as 2. Here is an example of when running some statistics. Mean, for example, makes no sense. If you ran a mean on a nominal variable such as gender, what would 1.25 mean in this context? Data can be ordinal, where values associated with that value represent rank-ordered categories so that the values have meaning relative to each other, such as low, moderate, or high. But the distance between each category doesn't have any meaning and may not be equivalent. Variables can also be interval, where the measurements are on a numerical scale with an arbitrary 0 point that has no meaning. For example, 0 degrees Fahrenheit means cold, not no heat. Similar to ordinal data, the distance between the points isn't the same across the scale. For example, 60 degrees is not twice as warm as 30 degrees. Finally, variables can have a ratio scale of measurement. In this case, values are on a numerical scale with a meaningful 0 point. $0 means you have no money. As a result, values can be compared in terms of their interval and ratio scales. So $30 is 3 times more than $10.